back. Now we're going to do the question and answer from the previous session. So, questions?
So, yeah, I haven't done any electronics with SMT because I've been out for 30 years, but is it as easy to get all the SMT components from the catalogs and kind of assemble them?
I'll walk you through the whole process, okay? The way, you probably don't want to be twisting the camera all that much. The sound, the acoustics in here are good enough that people pick it all up. Let's see, the way we do parts is, I always start with a place called DigiKey. DigiKey has one of the most excellent parameterized part selection systems out there. And so basically I try and find the part on DigiKey first, or find the kinds of parts I'm interested in. And then I get those part numbers, the manufacturing part numbers, and I go to a place like findships.com or octopart.com, and then you drop those part numbers in there, and it tells you all the vendors, availability, and pricing. Okay, and you know I'll design a board and order the parts, and I'll come back 6 weeks later to do the next rev, and the vendor that I'm ordered the first batch of parts on, they're gone. Okay, and I have to go order from another vendor. And sometimes you just lose. Okay, the part's off the market because it's really popular, and you can't do it. So a good example of that is the H-bridge parts. Oh man, they are so hard to find, and you know, the distributors struggle to keep those things in stock. So that's just an example of kind of the thing we wrestle with. Now, if you're going to buy 1 million of them, you've got the attention of the silicon company, and they'll get them to you.
Now, you mentioned the PCB manufacturing places. Are there some that will populate the boards for you as well?
Yes, there are. Okay, it costs. Okay, so
if you go beyond 100 or something, that's when it starts making sense.
After about 100, it becomes really easy. But there are places that'll do it for 1, 2 boards. You know, you just shove out the money and they'll do it. And a lot of outfits do just that. Okay, and they're here in the valley, so you know I don't know where they are. I don't have that kind of green on me to do it. But if you're paying an engineer some big bucks to sit around while some technician solders stuff, that's probably a good, you want to do it the most efficient way you can. So, okay. More questions? How many people here have a project that they want to do right off the bat? I know Danny does. Okay. And did I see you raise your hand, David? Yes. Okay. I figured you've got one. Okay. So it sounds like the rest of you might be looking for a project. Okay. So let me list off a few projects that are a possibility. Okay. How many people have heard of Raspberry Pi? Good, everybody. You have it? Raspberry Pi is a single board computer for $35. The price is the important thing here. He's got one. We've got plenty of them. And so I have a Raspberry Pi right on here. Okay. And I have an adapter board that adapts from the Raspberry Pi to my bus. Now there's another board out there that's gaining in popularity called the BeagleBone Black. And it would be nice to get an adapter board that adapts from the BeagleBone Black to the bus as well. Snack. Okay. So that's an example, okay, of kind of project. I tend to encourage people to use microcontrollers because once you've done a microcontroller project, you can do all the other your printed circuit board projects. But if you've never done a microcontroller project in surface mount, you haven't learned all the little issues that you have to worry about, like design for debuggability, stuff like that. And so that's why I want to encourage people to put a microcontroller on their project. Okay. So that's one. There's let's see if I can reach this board without knocking anything over. This is my Arduino board for hooking up. I actually have populated ones sitting on the board that you can look at, that you hook onto. But it actually has an AVR part on it. And as far as I'm concerned, the AVR, it's a nice processor, but there's better stuff out there these days. I mean, you know, the AVR was new, I think 10 years ago. You know, and this is Silicon Valley. 10 years is forever. So I personally think that it would be nice to have an ARM32 based board that you can plug Arduino shields into, because there's hundreds of Arduino shields. Okay, so I think that would be a good one. There's a system on there here that I think is really cool, done by Seed Studio, called Brew system. I have a whole bunch of things on here. I have an LCD, a joystick, a little OLED, buttons, some LEDs, and our real-time clock. All of this was like $60. Okay, there's this shield which goes on here, and all that stuff cost me $60. It's really a pretty nice system. I'd like it if we didn't have to go through a shield. We could directly hook this stuff up to the bus. So you're looking at like adding a button to a project for like a couple bucks. Okay, it's a pretty good little deal. So that one I think is a good one. Another one is we do a lot of robotics around here, and the sonars have just completely dropped in price. I don't have a sonar with me, but they cost like $1.50 now, just a little more. I'm sure you have one on your robot, but let's not bother. Okay. It'd be nice to build a board that can hook up those so that we can sprinkle them all over our robots.
You could use flexible PCB for that if you wanted to. So you could conceivably build a board where you hook 10 sonars on and wrap it around a robot.
Yeah, or you can just make a printed circuit board that's designed to hook onto the sonar and just use regular ribbon cable. There's lots of ways to skin this particular cat.
And sonar is a transponder with a...
It's a little sonar, sends out a ping and it returns back, and you can measure the distance. Okay. They used to be really popular on the old Polaroid Instamatic cameras. That's actually where we first got ours, and then those kind of went extinct. Then people started making more specialized sonars.
Is there any brain on it at all? Or is it
Yeah, there's a little microcontroller on it.
It's not just a microphone.
Yeah, it's just a little microcontroller. Okay. What you learn is that these microcontrollers don't cost much of anything.
Apparently not.
Okay. On one of the projects I'm consulting on right now, I think one based on an 8051 core, and quantity millions, is like 2.5 cents. It's really, it's astoundingly cheap. Don't quote me on that last number. They don't actually give me the final numbers, but they talk pennies. They don't talk.
All the IP is free. The 8051 is out of patent for
Right.
decades. So totally.
So that's why they use the 8051.
So we used to stuff PCBs, and apparently you don't do that anymore.
You do some of that. When I say the
phrase
through-hole,
has changed to something else now?
no, we do through-hole parts still. Okay, so that takes care of. That's what the stuffing is. Now, it used to be you would use an integrated circuit socket, okay, and solder that in, and then you'd stuff the IC in there, okay? Most of us have given up on the IC sockets, and we just solder directly in.
So you put this paste down and just stick it there, and it doesn't go anywhere on that side.
Yeah, that's the solder paste.
How do you deal with the other side and the other?
We will only be doing surface mount on one side in this class. Now, if you want to do a cell phone, that's going to be double-sided surface mount, multiple layer boards, ball grid array parts, okay, and a whole bunch of other stuff that I can't even think about. Okay, that's tricky stuff. You probably don't want to do that for your first project. Okay, I had one person contact me over email, and he asked about ball grid arrays, and I basically said, I've never done them, but I think they are within the realm of what we can do. What we won't be able to do with ball grid array, and by the way, a ball grid array is a square package which has little balls of solder on the bottom, which land on the thing, and when you heat it up, all the balls of solder melt, and the chip drops down and solders on. That's what all of your cell phones use, is ball grid array things, because they're really tight packaging. Okay, we'll be able to solder those, I think. but lifting them up and reusing them is basically out of the question. So that's the problem with ball grid array technology. So I've never done it, but I kind of hope somebody in the class wants to do a ball grid array just so we can experiment. Okay, so let's see, I'm listing out some ones. I'm pretty sure that David here is going to try and do the high current H bridge, or is well on his way.
We have high current H bridges already.
Yeah.
So we're talking about doing new revisions of that high current H bridge. So we actually have starting point designs for people who are interested in doing that, and that makes it an easier problem, and probably enhances people's learning as well, because many aspects of the design are already pretty good.
So, okay. A general purpose I/O board, I actually don't have one. It's one of these things that was so easy, but I never laid one out. And there's one that I really would like somebody to do, and that's to do our own JTAG adapter. We can buy them. They cost between $35 and $65 to buy one. But it's really nice to have a cheap one, and I think we can do one for probably closer to $20. So it'd be really nice to do one of those. I think we should have a low power H bridge so that for the smaller robots that we have lying around. So yeah, I just want to throw some of these ideas out at you. So that was me answering my own question. Other questions?
So when you solder something that's SMT, presumably the solder paste is such when it melts due to surface tension, it doesn't like leak all over the place.
That is correct.
So you have to be very precise how much solder paste you put.
It's actually, depending upon the part, you have an amazing amount of slop.
What do you do?
Okay?
Because if it goes wrong, then you throw away the whole thing.
No. If something goes wrong, you can usually fix it. Okay? It's actually surprising. It's actually easier to take a high pin count part off on surface mount than it is with through hole. Okay? On a through hole part, you have to snip the thing out, throw it away, pull out each pin, clean out each hole, and then put the new one in. In surface mount, you throw a heat gun on it, warm it up, the chip lifts off, you clean up the pads, you drop a new, put a little solder flux down, and you solder the new one down, done. Okay, so it's one of these things. Some things are easier, some things are harder. As I say, when you do ball grid array, you get one shot, and if it doesn't work, you're basically going to have to throw the thing away. You probably will not be able to lift you might be able to lift it off, but you probably won't be able to clean it up enough to solder another one down. So you basically have to throw that board away.
The first time I tried surface mount, I was amazed and surprised at how easy it was if you have the right equipment.
Right.
Right.
Okay.
Really, actually, much better system.
Yeah, it really is.
Even
Okay. So, further questions? Going once? Going twice? Okay, so we'll push the red button.